And I'm sure throughout today you must have joined session and went to a lot of talks where the topic was about data and Gen AI and how you can leverage AWS services and some of the AWS solutions from our partners as well to reimagine your business and build new customer experiences. That is great. But how about actually hearing firsthand from a customer that have actually gone through that journey? So in this session, I'm really excited to have Creditsafe join us on stage, who will be sharing the journey around the evolution of the data platform and how that platform is driving and empowering business decisions across Creditsafe. My name is Ozioma Ozegu, and I'm a Principal Solution Architect at AWS, and I'm joined by my colleague here.
Hello everyone, it's Vedi. I'm a Technical Account Manager at AWS. Glad to be here in this session presenting with my colleague Ozzy with the presence of our customer Nabil.
Good evening everyone, my name is Navdeep Sharma. I'm System and Product Architecture Director at Creditsafe. Really happy to be here.
Thank you. So here's the agenda of what we're going to cover today. So myself and Mehdi will begin to talk about what do we mean by modern data architecture on AWS and how can you go about building a modern data architecture on AWS. We'll then hand over to our customer, Navdeep, who will be diving deep into how Creditsafe have evolved the data platform on AWS, some of the challenges they face along the road, but most importantly, what are the key learnings, which I think you'll find really useful as well. So why modern data architecture? So I speak with customers on a regular basis, and some of the 5 key themes we hear from our customers that is driving customers pushing for modern architecture are these 5 key points. So the first is around, as we see data growing, customers want to be able to make better and faster decisions. And when they provide services to their end customers, customers always want more. So customers are looking for ways to use data to improve customer experiences and also drive customer loyalty as well. And you agree with me that in the market today, data is becoming a new competitive edge. So businesses want to stay ahead of the competition and see how they can use data-driven insight to outpace competition. And as you begin to also think about the future, customers are beginning to think about what next for their business. How do they transform their business and imagine new products and services that will transform customer experiences? And data will be pivotal to this. And that's why customers are thinking about how do we modernize our data platform. And finally, around business processes. The number of legacy business processes that can be reimagined with data and also save costs for the business. But we know that there are a number of challenges that customers come across along this journey. So we are seeing massive creation of data from different sources, from terabytes to petabytes of data. Data being stored in different silos, which can be very difficult when you want to combine these data sources to be able to derive insights. And of course, for you to be able to make the most of the data you have, you need experts in data analysis and AI and machine learning as well, which we agree that there's a little bit of shortage in the market around these skills. But most importantly, which is still job zero for us at AWS, is around security. How do you make sure that you secure your data with the right privacy and governance in place to make sure that only the folks that need access to the data have the access to do the job they need to do or to derive the insights they need? And that is why when we speak to customers, we really kind of underpin these 3 key pillars of modern data strategy. So the first is around modernization. So how do you take your legacy data store and move to a purpose-built data store that is cloud-based? So for your structured data, how do you store that in a purpose-built structured database that is suitable for that data? And the next is around unification. Like I talked about those silos. How do you break down those silos and combine data from different sources to be able to make it easy for you to derive insights? And the last is around innovation. Once you set out this foundation, it's now all about how do you leverage AI machine learning tools and data analysis tools to be able to derive insights from your data. But I guess the question is, how do I take these steps? Do I do them one after the other, or do I do them in parallel? And I can say, depending on your use case and depending on your business challenges, this can also go in parallel. But when you begin to go through this journey, there are core building blocks you need to think about as well. And I've kind of put those building blocks out here in the slide as well. So first, you typically have data being generated by different sources. This can be apps, this can be devices, or this can be potentially humans as well. You want to be able to capture this different data from different sources, whether you're talking about structured data, unstructured data, or streaming data, and store those into purpose-built databases or data stores. And then the next key component you need to think about is around how do you break down the data silos across these data sources using things like data lakes. But of course, with the right governance put in place and a catalog to make sure that across the business, you have a good visibility and the metadata of all the data you have within the business, the type of data, the fields within the data, to make it easily searchable and queryable as well. And once you set out this right foundation, it's now all about how do you use the various analytics tools and machine learning tools to be able to derive insights, but also create new customer experiences as well with AI and machine learning models. I would now like to hand over to my colleague, who will dive deep on what are the different AWS services that can help you with these building blocks to help you get started with your modern data architecture. So over to you, Maybe.
Thank you very much, Ozzy. Now that we've gone through the most important concepts about building modern data architectures, let's see how we can leverage AWS services to build an effective data platform. Modern data architectures rely on 5 main pillars. First is scalable data lakes, with Amazon S3 as a key component for storage that allows storing a large amounts of data in structured and unstructured format. Amazon Athena can be plugged on top of Amazon S3 to add simple capabilities to your data. Then second is purpose-built data services. So AWS customers have access to a catalog of data services that are tailored for their specific needs and types of workloads. Examples can be Amazon DynamoDB for NoSQL, Amazon Aurora for databases, Amazon Redshift for data warehousing, or Amazon OpenSearch service for search and log analytics. Third is seamless data movement. So your architecture must allow data movement across all of your components. And for that purpose, AWS Glue stands out as a service that allows interacting data across different sources and destinations. Fourth is unified governance with AWS Lake Formation as a central component to ensure governance and data access enforced across all of your data components. And then 5 is performant and cost-effective, and all those purpose-built services have been designed to be performant and cost-effective. Now, before building our data platform, we need to focus on a key topic, which is data discovery. Data discovery is the first step in building a modern data architecture. So the process begins by defining business values, and this is done through gathering insights to drive outcomes such as growth, efficiency, or innovation. And this sets the stage for everything that follows and ensures that the project is not just about data for the sake of data, but it's directly tied to tangible goals and outcomes. And then next, we identify user personas. And user personas are mainly the stakeholders that will be interacting with the data. So different stakeholders, such as data scientists, analysts, or business executives, can have different expectations from this data. This is why identifying those personas helps in tailoring data solutions that address specific requirements. And then with those goals and users in mind, we then identify data sources and tools to bring this data into our platform. Once we know what data we have and where it is, we address the data storage and access. And this step ensures that we have access to the right data at the right time while maintaining security and compliance. And then finally, we move into data processing, and this step leverages the identified business goals, personas, and data to build workflows that extract, analyze, and transform data into actionable insights. Now, after the data discovery comes the design and build of your data platform, which consists of 6 foundational layers. First one is data ingestion, and the purpose is to bring data to your data platform from different sources identified earlier. And second is data storage, and once this data is ingested, it needs to be stored efficiently to support both structured and unstructured data in a flexible and scalable manner. And then third is data cataloging, and in this layer, the focus is on organizing your data and metadata to enable discovery. Then fourth is data processing, and after cataloging, the next step is to create data pipelines to transform and prepare the data for analysis. Then 5 is data consumption, and in this layer, we focus mainly on making data available for end users, whether for use cases like analytics, machine learning, or reporting. And 6 is security and governance. And this final layer ensures that data storage, processing, and movement across all these layers is done in a secure and conform manner. Now, let's illustrate these layers by walking through a modern data reference architecture in AWS. So first, as we said, we identify our data sources, can be databases, file shares, SaaS applications, and so on. And first step is the data ingestion, which can be implemented using services in AWS, like AWS Data Migration Service, to migrate databases, or Amazon Kinesis to process streams of data. Then second layer is storage, and here we need to store our data in a scalable data lake, which is, in our case, Amazon S3. Then this data stored needs to be processed, and for that purpose, we have AWS Glue as an ETL service. Additionally, we have AWS Glue Data Brew, which offers a no-code experience for non-developers and non-technical persons to interact with the data. And then this data transformed will be stored and consumed by multiple services, such as Amazon Redshift, which is a data warehouse, scalable data warehouse that allows you to query petabytes of data. Or for business intelligence requirements, we have Amazon QuickSight, which allows users to visualize and build dashboards on top of their data. For AI and machine learning requirements, we have Amazon SageMaker, which allows to build, train, and deploy machine learning models in an easy and scalable manner. But most importantly, all this architecture is underpinned by unified governance using AWS Data Foundation. Now, enough of the theory, let's go through a real-world use case with Creditsafe that built their data platform on AWS services, and we'll see the unique choices that have been made to meet their requirements. Over to you.
All right, thank you so much, Mehdi. At Creditsafe, we've been investing past 3 years to build the modern data platform. And over the past 3 years, we have learned quite a lot through our successful and failure experiments. In this talk, I'll walk you through the entire session in three parts. First part is I'll introduce you to the Creditsafe, what we do. In the second part, I'll take you through the evaluation of our data platform and architecture. And in the third part, I'll share some of the key learnings that we had in working with AWS. So, Creditsafe is a credit reporting company. The reason for our existence in the world is to establish trust between two business entities who do not know each other. Imagine that you are a small vendor, you have received an interest from another business entity for merger, for a deal. You don't know anything about them. Now, Creditsafe's comprehensive data gathered from over 9,000 data sources across the world help you understand businesses better, and we provide you with the information such as their financials, their shareholder and directors, if there's any court judgment against these companies, and how long does it take them to pay off their invoices, and more importantly, analytics such as what's the likelihood of this company going bankrupt in next 12 months. Now, looking at the Creditsafe in a single picture, over past 25 years, we've grown significantly, and we operate currently in 200 plus countries. Many of these countries, we hold data natively, and we ingest from over 9,000 data sources, but we also have API partners that help our customers get the right information that they need. These 9,000 data sources help us with the business changes that's happening across the world, and on a daily basis, we are capturing more than 10 million changes associated with business information across the world. Just by looking at the usage, our API and web customers have used our platform to retrieve more than 357 million credit reports in 2023. It would be an understatement to say that Creditsafe has done fairly well in its growth, and anyone who's been associated with a company that's grown at this pace know that all this growth will come with some challenges. So this is the second part of the talk where I'll talk you through the evaluation of the architecture and our data platform. The first state is our legacy state architecture, where early in the process, when we launched into a new country, we started operating into a new country, we had it tested and tried architecture pattern and model, and we launched the same successful model into multiple countries. So let's take an example of UK. We aggregated data from multiple sources, such as company houses, registry offices, court judgment banks, and media, and we aggregated information about businesses and put them together for the consumption through API and bulk for our customers. We built API web platform on top of this, and we were up and running. We established this successful architecture. It's a typical 3-layer architecture, and we launched into more countries. So looking at the next set of countries, it was same for France, Sweden, Germany, US, Japan, and we've rolled out into more and more countries. Now, over the years, Creditsafe started building global products based on this local data. So now we no longer just delivering credit report, but we were also building more products such as monitoring and enrichment. The purpose for existing for monitoring is to actually notify customers whenever there is a change in their company or portfolios. So if a customer comes back to us and says, here's the list of companies that I'm interested in, and obviously that could be widespread across the world, we notify them whenever there is a change in the company. So changes such as a new director has joined a company changed their addresses, or there is a new court judgment against that company. Each and every event that customers are interested in and they have opted for, we send notification. But obviously there is a very obvious bottleneck that you'll realize, that as we scaled into more and more countries, there are almost 50 country databases and 6 to 7 product databases. And every night we've been replicating information going from country databases to product database to actually build this global product on top of our local data. Looking at some of the limitations that this architecture was throwing at us. Obviously, there was lengthy procurement cycle because of this being on-premises solution. We had multiple data replication going across from country databases to product databases. The country databases has been in the silo, sitting in the silo. So to be able to link an Irish company with its parent company sitting in US wasn't really a straightforward task. We always procured hardware for the peak performance, even though there may not be any usage going to that hardware. And because we were loading the same data onto the servers that we were delivering data from, there was always job contentions between bulk deliveries and data ingestion. Now, the second part of, second state of our architecture, which I'm going to refer as intermediate architecture, is where we introduce Redshift into our architecture. And we took the ingestion process and we streamlined to all the country's data being ingested into Redshift. What it really meant for our products is now launching a new product did not mean that we have to copy data over from 15 different country databases into a single product databases. All the product database relied on getting its feed and daily changes from the Redshift, which not only reduced our go-to-market time for launching any products, but also reduced the number of jobs and the operational support that we had to provide for these data pipelines. This was really good. It simplified our architecture fairly well, but it had some limitations. Most of our products were focused on the current view of the companies. So if there was a company which was paying its vendor quite late and not paying their invoices on the time, it could very well be erased if they kept their record clean for a couple of months. There was no purpose-built system that was tracking the ongoing changes in the business. So all the changes captured depending upon the metadata such as last modified date or a hash key, which meant that there were a lot of noises for the customers that they were receiving. We didn't have any historical data to build new models and backtest by going back into history, and it was a long time to actually build an analytics model and test it on the new data. There was still data replications happening, going from a single Redshift cluster to multiple product databases, and the amount of growth that we've been seeing in our data, obviously the transactional databases performance have been degrading. Like anyone else, we've been scraping for optimization sometimes by optimizing our SQL query, building new indexes, archiving old data. And because our customer delivery was still based on Oracle servers, we continued to struggle due to hardware limitation and how many parallel jobs we could run. So in 2021, we sat down, we've analyzed our usage pattern, which was primarily bulk delivery, analytics usage, and transactional API customers. And we thought to build a new data platform with few foundational requirements. First, we wanted to build a single source of truth. That meant that we didn't want to be in a situation where one of the product databases job replication has failed, and one product is saying the company has gone bankrupt, whereas the other product is saying that it's not. We always wanted to rely on single source of truth. We wanted the ability to access the historical data, not just for us and our analytical users, but also for our customers, because in this industry, it's good to know how the company currently looks like, but it's even better to know where they're coming from, what's the historical trend was like. You can imagine that whenever we launched a new product, we've always launched a traditional 3-tier architecture with the API, UI, API, and databases, which was fine, but it wasn't fast enough at the speed that we wanted to build the software and solutions. Learning from some of the pain points from the past, we didn't want changing of the data impact our system at all. We wanted to minimize the number of changes that we actually have to do, and any data changes shouldn't trigger a build in our production pipelines and code changes. And the last but not least is because of all the data lineage data redundancy and the replication, it was hard to keep track of the lineage, and there were multiple mapping documents being maintained to make sure that we are delivering the right company attribute from the right locations. So, with this foundational requirement, we went on to design the current architecture where Creditsafe currently sits and is moving most of its product to. First of all, what we did is we streamlined the ingestion. All the country databases have started to ingest into Redshift, and there is no Oracle there. The second part that we did is actually we removed all databases from our architecture. We no longer have a transactional database to serve our customers, and primarily because there are usage patterns for all these databases. For example, if you take DynamoDB, those are latency sensitive databases. Redshift is a data warehouse solution that could be called as a throughput sensitive, but more about there was no one single solution that could have kept up with the growth that we were foreseeing for next 10, 15 years. So we dropped our databases, we've unloaded the data from Redshift, performed the ETL, and the job of the ETL was to actually take the table view of the company from 20, 30 different tables and build a single JSON company reports per object into an S3 location. What that meant, now the company reports are cached and ready to go. And in the past, when a customer requested a company report, we were having to go into 20 different tables and build those segments into a single JSON reports. Obviously, the latency was not as great as it could have been. Now, since we have the company report sitting as S3 ready to go, we've started delivering the data to our other set of products, whether it's a customer's delivery or the product reliance on the data. So, to understand some of the learnings that we had over the past couple of years, I think it's important to understand how we've placed our company reports and JSON structure. It looks something like this. We have a container of 10. In a single container, there are 10 companies and that have a first 11 digit common, and we just remove the trailing digit and combine them into one. And within a container, there's also delta file looking at the previous, as it changes between previous report and current report. There's also an epoch, if you've noticed, into the path, which basically is the number of days since the launch of the platform, which allows us to deterministically find an historical view of the company report. So if you want to have a look how your company was 3 years ago, you could go and make a query, and this will give you a view of what a company looked like 3 years ago. Their financials, their directors. So what that meant is if someone joined the company and they left, there is always a track of that. Technically, what it also gave us is it gave us a reduction in almost 10 times when dealing with the data transfer in bulk. So when most of our big customers ask for data, it's usually give me the entire set of countries or the changes. And now, rather than downloading one object at a time, we are downloading 10 objects at a time. When we did the experiment with this and wrote one single JSON object into S3, our API latency was around 50 to 60 milliseconds. API gateway just going straight to S3 and pulling the object out. But even with the 10 container of a tar file, we brought the container into the Lambda and exported it and delivered the company report. It was still 100 to 120 milliseconds, which was far better than our previous API latency time. And with Epoch, obviously, we were able to deliver point-in-time information. We also built filter index, temporal index, and lookup index. So for any databases, there are three major components: storage, indexes, and query engine. For storage, we've used S3. For query engine, we've used Athena. And for indexes, it's a combination of Parquet sitting behind Athena and Aurora serverless. Filter index, the idea of filter index is when a customer doesn't really know what type of companies they're looking for. So imagine you have a small company that builds furniture, and if you want to know that who are the new restaurants in the Dublin area, You can perform a query for the industry of restaurants and food, beverages, and get the list of companies based on their incorporation date. And that's what filter index allows you to do. Temporal index maintains the history of the company, and you can take the same list of companies that you had and ask for any changes in past 3 to 4 years and say, tell me when there was a change in their directors or when there was a court judgment against them, and it will come up with the exact date when there was a change. Lookup index is simply a translator from the external identifier to internal identifier. You can take a publicly available VAT number, registration number of a company, and get an internal safe number, which our entire architecture is based on. All right, this is a little bit busy slide. I think I'm not going to go into too much detail on this one. The only thing I'm going to put focus on is how we use Redshift. Redshift is, as a data warehousing solution, has solved a lot of problems for us. But important thing, how it helped us to achieve this architecture is we use something called Redshift data sharing, which allows you to share the underlying data without impacting the compute of your producer cluster. So we built producer cluster. We share, producer cluster was responsible for bringing all this country specific data into Redshift. And we we built consumer clusters to actually have the access of the data sitting in the producer cluster. So what that meant is the data onboarding has never been impacted by the processing and loading and ETL job that we perform downstream. Another use cases that we used Redshift for was actually just reporting and monitoring for the data quality and data coverage. And obviously this also has no impact on either of the processes that we perform. Now, just by the choice of technologies and how we designed it, the architecture itself is really horizontally scalable. We've been launching more and more countries without having an impact on our processing. We built packages with purpose. Very specifically, we haven't used any big data framework. Most of our code is written in Python, and there are small packages which does the job and can be deployed either on a Lambda function or a big EC2 machine. For an example, change detection, looking at a version of company report from yesterday and today, and see if there is a change, and there is a meaningful change, that package that was written in Python can easily be taken out and be replaced by Rust package. Historical backfill is a big capability that we built, which means that if we go in a new country and launch into a new country today, that does not mean that we'll have data only from today onwards. Given the data is available, we can launch into a new country and still have historical data from last year or 2 years ago. I think the schema registry is an important one because it allows you to change the data schema and without actually making a piece of code changes. So whenever there's a new attribute available or a data type changes, we just simply change the schema, and the data processing, delivery, everything works off the schema registry, and there's no code changes required. All right, this is the last part of the talk where I go through some of the learnings that we had, and S3 being the crown jewel service for this architecture, I wanted to share some of the learning associated with S3 itself. So this is straight from our AWS bill from September 2024, right? How we use S3 is quite extensively, to be honest. In September 2024 itself, we paid 14,000, close to 14,000 in just in S3 bill, which is half of our entire AWS usage. But what that means is we have captured data for over 3.5 years into 256 terabyte of the storage. In month of September, last month, which is alone, we performed 33 billion read operations on S3, and this is primarily associated with delivering the company reports back to the customers. In the write operations, we performed 1 billion write operations to S3 in just the month of September. Now, linking back to the tar container, we combined multiple companies, 10 companies in fact, into a single tar container. If we wouldn't have done that, this bill could have been 10 crores. And given the data size that we are growing at, it's really going to be beneficial for just even from the compute perspective and speed perspective, because to download a single tar container is almost as the same time that it takes to download a single JSON company reports. So we also deliver data much cheaper and much faster. One of the first learning that I'm going to talk about is understanding the S3 prefix and how S3 works in terms of prefix and partitions. You're allowed up to 5500 read operation and 3500 write operation per prefix, but that's not how it works straight out of the box. S3 does something called auto partitioning. It analyzes your usage and creates more and more partitions in your bucket. So in this example, you can have entire 5500 read and write operations stick to your country itself, or if your usage is higher, then it can go even further to allow you scale. But when we started delivering the informations using our bulk delivery mechanism, what we started to see is a lot of 503, which is like slowdown error from S3. S3 has not been able to cope up with the type of traffic that we've been throwing at it, which meant that our jobs were being delivered quite late. And what it does in the background, that if you continue persistently are making the usage, it takes 30 to 60 minutes to add more partitions, so your users will be able to keep up with that. Now, in this, we work with AWS to actually create something called pre-partition. Now, what pre-partition does is, you provide a pattern of the bucket, and AWS can use that pattern to create more partitions behind the scenes. Whether the partitions are created by auto-partitioning or pre-partition, it will phase out if it's not being used. So it's important that you keep an eye on 503 errors. If you're starting to get a lot of 503 errors, the advice would be pre-partitioning your bucket. And we've also built something called retry queues, which meant that whenever we figured out that there's a partition which is too busy and unable to serve data, we just put it in a queue, move on, and come back to it to download the file. Now, important takeaway here is, if you're looking to release something, a new product, or based on S3, I think and you're expecting a spike of traffic, I think it's really important to go and get pre-partition created based on your expected usage. The next one was try and find a sweet spot between S3 and Athena cost. If you know Athena, it's a serverless query engine that allows you to scan data sitting in S3. Now, the cost of Athena is based on how much data you're scanning. If our temporal index is designed like this, that means there is a partition by country, partition by date changed, partition by segments. It will only scan the data that you query for partitions. We initially had the partition just by date, but by analyzing the usage, we've been seeing a lot of our customers making query for a specific segment. So what we thought is it would be a good idea to actually create partition by segment. So we added the additional partition by segment to actually reduce the amount of data scanned and hence reduce the Athena bill. But what it resulted into is a spike in the S3 cost, which was quite funny because it was an exercise that we did to reduce cost. What we figured out eventually is actually Athena, for each query, Athena makes a list bucket call for each of your partition. So it will go into each of the partition and will perform list bucket call. So suddenly, in the effort of reducing Athena cost, and we did see Athena cost going down, we increased our S3 cost by a huge margin. So we obviously reverted it back to the daily partition, and it was the sweet spot between our S3 and Athena cost. I think one of the last technical learning is the inventory report, and it's one of the underrated feature I feel like of S3, which no one talks about. If you have a lot of objects in your S3, it's not possible to keep track of it manually. if you want to be on top of the S3 objects, I think I would highly encourage to get the inventory report. What inventory report does it lists your list of objects in a CSV file along with bunch of other metadata, that when it was created, what's the size of the object, and a few others. How we currently use it is actually every month we get a inventory report of S3. Just for reference, we've got over 60 to 70 billion objects in a single bucket, which meant that it was really hard to keep on top of the S3 inventory list of objects that we had in S3. Now, what we do is just use S3 inventory report to detect anomalies and perform the checks if the objects are reducing or not. Moving on to the mindset shift, I think building single source of truth sounds good, but organizationally it's not that straightforward. You're basically telling a bunch of other teams that you no longer can perform an alter statement query on the database because there is no database. And if you want to correct a piece of information, you have to do the due diligence that how long the information has been wrong for. Building a producer-consumer mindset where if you're on the left-hand side of the data flow, you have to be responsible for the consumer of the data. It could be customer, it could be your internal team, and you have to be almost shape this three-tier architecture, which is UI, API, and database, and put it in a flow and change the mindset. Zero-touch operations, I think many of the organizations have grown in the mindset of zero-touch operation for the production, but for the data it's much harder because whenever there's a quality check failures, how do you handle that? That's a mindset shift as well. Now, lastly, I'm just gonna look into some of the future explorations that we're gonna do over the coming year, and looking at obviously like most of the other companies in the industry, we're looking to leverage AI for our operational efficiency, data quality metrics, delivering right customer values. We're launching Redshift serverless, one for each country. Hence, when we are performing data ETL jobs and we are unloading the data, one country job doesn't need to collide with the other country. Now we have gathered over 3.5 years of the historical data. We want to look into the industry trends and see that which trend and which industries have impacted the economics of the world. And in the first half of the next year, we are also adding 20 additional countries on our data platform, which means that over the growing size of the data, we are not just growing in terms of the companies and segments, but we are also expanding our footprint across multiple countries. All right, thank you so much for listening to me. I'll hand it over to Mehdi. Thank you.
Thank you very much, Navdeep, for this great feedback on Creditsafe data platform. I hope you've learned a lot through this session. And to continue learning, we've added 4 additional resources on what is a modern data architecture and how to build one. The third link is a workshop to gain hands-on experience on data engineering. And the fourth is a link to our training platform, AWS Skill Builder. Now, thank you very much for attending this session. Please feel free to reach out to us if you have any questions. And before leaving, please complete this survey by scanning this QR code. This is very important for us to know how we did and how we can improve these sessions. Thank you.